Okay, let's finish 2.7 with this one last example that puts all of the properties and characteristics that we've seen earlier into one problem. Oh my goodness, I can't read that. Let me look at that. Hold on a second. Okay, that's actually an x minus 3 squared. So we're working with a parabola function. And x minus 3 squared. And there's a condition where x is greater than or equal to 3. Now remember, parabolas are not one-to-one functions, so I can't find an inverse of it. But by making this restriction on the end, that means I'm only looking at the right half of the parabola, which forces it to be a one-to-one function, and I can perform any of these inverse operations on it. So how about we find the inverse function first? So let's go through our steps, the R, S, S, R steps, to actually find the equation. So first R means replace f of x with the letter y. Then we need to swap out x's and y's. Then we need to solve for y. There's our y we need to solve for. So I'm going to have to first get rid of the square. How do you get rid of something? How do you get rid of a squaring operation? Well, we're going to have to square root both sides. So square rooting both sides cancels the square. The square and the square root cancel. So I'm left with the square root of x equal to y minus 3. But I did forget something. Every time I take the square root of both sides of an equation, I need to incorporate the plus or minus. I'll explain to you where that's going to go. Let's just finish solving for y. Let's just get y by itself by adding 3 to the other side. Here's what it would look like. Plus or minus the square root of x plus 3. There's our equation for the inverse. But now we have to decide. I can't have a plus or minus because if you remember earlier in the semester, if we had the plus or minus, then it wasn't a function. I have to choose either the plus or the minus, and there's something here that's telling me that I'm going to choose the actual plus on the square root and not the minus. Any idea what that is? Got to choose plus or minus, and I'm going to choose the plus because look back over here with our parabola. Were we considering the left half or the negative half of our parabola, or the right half, which is the positive half? Because we're choosing the right half, which we can think of as the positive half, that is telling me right now to choose plus. We're going to choose the plus because we have the right side of a parabola. If we were considering the left side of the parabola, we would have to choose the minus in this case. So now let's list out our inverse. F inverse of x is going to be equal to the square root of x plus 3. The positive version of the square root of x. There's our equation. Now let's go over here and graph both of them on a coordinate system. So f of x is x minus 3 squared, which is a parabola that's been shifted to the right 3 units. So I'm going to draw half of a parabola that's been shifted to the right 3 units. There's f of x. Now let's graph the inverse. The inverse is a square rooting, the square rooting function that's been shifted up 3 units. So the square root function that's been shifted up 3 units looks like this. There's the inverse. Now, do these guys exhibit the symmetry we talked about the line y equal x? And they do. Both figures are symmetric. And if you also notice that ordered pair thing, this is the ordered pair 0, 3. This is the ordered pair 3, 0. We see that swapping thing with the x's and y's. Finally, for this problem, let's state the domain and range for each of those. So for my blue function, well, let me go with the orange one first. For f of x, let's find the domain and the range. So that's easy enough from the graph, and actually they did state the domain for f of x in the statement of the problem. Right here is the domain for f of x. X greater than or equal to 3, or we can write in interval notation 3 to infinity. Let's get the range for the orange function, the f of x function, from the picture. So domain as I go left to right is 3 to infinity. The range as I go bottom to top is 0 to infinity. So I could say y greater than or equal to 0 or 0 to infinity. So there's my domain and range for the f function. Now let's consider the blue function, the inverse function, and let's find the domain and range for it. What did we say earlier about domains and ranges for functions and their inverses? They're actually switched. The domain for the f function becomes the range for the inverse. So I don't even need to do any work here. The range is going to be 3 to infinity. And the domain is the range that I had before, 0 to infinity. So remember, range becomes domain, domain becomes range. Those guys are swapped. Now you can verify it from the picture. Look at the picture of the blue function, that's the inverse. As I go left to right along the x-axis, that graph starts at the 0 mark on the x-axis and continues to infinity. As I look at the y-axis, go from the bottom to the top, my graph starts at 3 and goes on to infinity. So that's how the domain and range will come up from the function to its inverse. We can just swap them out. Don't forget to do the exercises in the book, find the application and the critical thinking. All these here at the top are in Course Compass, but these type usually are not.